All right, 2.5, solving multi-step equations. So sometimes this will require combining like terms and then using principles of equality. So this, based on what we've learned in these past few sections, take 30 seconds, give this one a shot, okay? See if you can solve for the value of y that would make this a true statement, all right? 30 seconds, go. All right, so we'll come back to that problem, but just remember, we're looking for the principles of equality, but before we use any principles of equality, we should be looking to combine like terms. So for that problem, when I say combine like terms, I would be looking on one side of the equal sign and then the other. So make sure you're not looking at the positive 4 here and the negative 31 as like terms that you can combine. They are like terms, but they're on different sides of the equal sign. So if you needed to separate that right now so you don't start combining on both sides of the equal sign, that would be good. So I look at this negative 6y on the left here, and I can see that there's this like term with this negative 1y. And if I were to combine these, how many y's would that make? Well, negative 6 minus 1 is going to make that negative 7. So now the new equation is negative 7y plus 4 equals negative 31. And I have an equation now that is like the problems from that last section. So I'm looking to make a 0 first to isolate the y's, that negative 7y, right? So I would have to zero out that plus 4 by subtracting 4 from both sides of the equal sign. And that does zero that out, so I keep that negative 7y. It's just going to drop down. The equal sign is still there, so I got negative 31 minus 4, which is negative 35. So this two-step equation now becomes a one-step equation because we just did one of the steps. And to finish off and make this 1y, we'll just divide both sides by negative 7. So that makes that a 1y. Negative 35 divided by negative 7 is 5. So y is 5. Sorry, that is a y right there. Y is 5, and we'll just double check. So negative 6 times 5, that would be negative 30. And then plus 4, that's going to make that a negative 26. And then minus 1 times 5, so that's just 1 times 5 is 5. So minus 5. Negative 26 minus 5 is negative 31. So that checks off. That makes it true. And I know that y equals 5 is my answer.
I have a question.
All right, so a problem like this one, first thing we should do is look to distribute that negative 6, okay? So first off, I distribute it to the 8x, right? So that's negative 6 times, or negative 6 groups of 8x, which would give us negative 48 x's. And then we'll distribute it to the 9 as well. So negative 6 times, that's a positive 9. Now again, I'm just going to show this as negative 54 as minus 54, okay? And that way the equation's already simplified. And now this equals negative 36. So that was one step. And this now has become a two-step equation. I should be able to solve this in 2 steps. So the first thing I'm going to do is zero out that negative 54. And to make a negative 54 0, I'm going to have to add it to itself. So plus 54, or add the opposite, I should say. So that does zero that out. So I'm left, now I'll drop this negative 48x. And negative 36 plus 54, I believe that's 18. I see. 30, 40. Yeah, it should be 18. That's weird. Let me just double check that. Okay, so I didn't expect to see a fraction. I wouldn't expect to see any on the homework, but the process is still the same, okay? Even if it is a fraction, we just want 1x there, right? So I take that negative 48 divided by negative 48 on both sides to make that 1x. And 18 over negative 48. Again, we're not concerned about the answer too much here, but that should be negative 3/8. So that's a simplified fraction. I would just, again, I wouldn't worry about seeing these on the homework as the answers as fractions, but I guess it's good practice to see. So just checking that, that'd be negative 3 plus 9 is 6 times negative 6 is 36. So that checks off too. All right, same idea on this one, but there's no distribution, but we're looking to simplify with any like terms first. And this problem has like terms on both sides of the equal sign. So I'm going to start on the left side of the equal sign first. And I'm just separating that with that green line there, so I know I'm not getting both sides of the equal sign mixed up. Now, negative 3 minus negative 6, I would change that to plus positive 6. Negative 3 plus 6 is positive 3. And then this should equal the other side, which has a set of like terms as well, 18x and negative 17x. So for x's, 18 minus 17 would be 1x. And then we still got that plus 9. So really, this is a one-step equation from here, because I'm going to zero out that plus 9, right? We'll make that minus 9 on both sides. So I'll drop the 1x. 9 minus 9 is 0, and 3 minus 9 is negative 6. Now, we always want the 1x, so even though I've got a 1 here, some students at this point would say, well, I need to divide both sides by 1. Well, still x is negative 6, okay? So you could have gotten it here. You could have gotten it here. It doesn't really matter. It's the same answer. Let's go ahead and check, though. So we've already evaluated negative 3 plus 6, right? It's 3. So whatever I get on this side, I should get 3 as well. So we'll do 18 times negative 6. Now, what the heck? We'll show the work on this one. Let's see. 18 times negative 6. I know it's a negative. So that'd be 48. Carry the 4 is 10. And then we got 17 times 6 as well. So that'd be, there's a 4, 102. So that's 108 minus 102, which is 6, and then plus that 9 right there. So yeah, that checks off. That becomes a 3, which makes this a true statement. So x is negative 6 is the correct answer. Yeah, let's go back to that. So it's that should have been a negative 108 because that was a negative 6 right there, right? Same with this one, 17. So that was a negative 6 plus 9, which is positive 3 right there. So I'm sorry. So
Okay. I was just gonna say that. Just kind of threw me off right there.
yeah. Now, please don't let the length of these stop you from at least trying them, okay? But a problem like this one, again, if we focus on this one step at a time, it should become pretty clear as to what we should do and simplify the problem even in our mind, so that we're not focusing on the whole problem at a time. All right, now if you're wondering on this one, what should we do first? It's a good question, and we should wonder it. But like you could say, well, do we combine like terms? Do I use principles of equality? And the real answer is you need to distribute first. Because before we do any combining like terms, we shouldn't see any parentheses, okay? Now, the other question with this distribution, right, because we're just focusing on this one part at a time, is what value am I distributing into the parentheses? And the answer to that is it's not 6, it is negative 6. Because remember, we're taking the sign to the left as, the operation to the left as the sign. So that's really negative 6. So I would start with negative 6 times 1x, which would give me negative 6x's. And then I've got negative 6 times 3, which is negative 18. Now, remember that positive 3 was because it was plus 3, right? But when I multiply it by negative 6, it becomes negative 18. I'm just going to show that as minus 18. So let's rewrite the full problem now. Well, now that we've gotten rid of the parentheses, we can focus on combining like terms. And there's a few sets of like terms, right? Like the 6 and negative 18, which are both constants. So that's really just 6 minus 18, which is negative 12. Next, we'll look to combine the x's. And again, yes, we're just focusing on one side of the equal sign. So negative 6x and 9x's would give us a total of positive 3x's. Now, I'm going to say this again. If you had written this as 3x minus 12, it would be the same thing. So the order of these don't matter as long as the terms have the same value. Well, there was no like terms to combine on the right side of that equal sign, so it's still just 10x plus 7. So this is my new equation. Now I've got x's on both sides of the equal sign, and before it was very clear what we wanted to make 0. And the truth is, on this one, it doesn't matter what value you make a 0, as long as it's one of them, okay? In other words, you get to choose which side you want the x's on, and you get to choose which side you want the constants on, or just the numbers, right? So for this problem, I would say, not that you have to, but I'm just going to say, you know what? I'm going to put my x's on the right. All my numbers should be on the left. So in other words, by the time I'm finished, I should get x equals like this. Now, there is a reason why I'm doing this, is because when I put the x's on the right side right now, and we'll see this, is it's going to make the coefficient of x after this operation positive. Most students don't like to see the coefficients as negative either. So I'm purposely putting the x on the right, but I could choose to put them on the left as well. And I understand some of this may not be making sense right now, but hopefully it will. So with the x's on the right, that means that this positive 3x, it's on the wrong side of the equal sign. So I'm just going to zero that out. How do I zero it out? Well, it's a positive 3x, so if I subtract 3x, it's going to be a 0. It's going to zero it out. But if I do it to one side of the equal sign, principles of equality mean I've got to do the other side as well. So that becomes 0. I'm going to drop this negative 12 there. And this would equal 10x minus 3x is 7x. And then we'll drop that plus 7 as well. Well, that's great. And I want my x's on the right. That's a 7x, by the way. But I don't want that plus 7 in black on the x side of the equal sign. So I also need to zero that out. So minus 7 on both sides. Looks like we may end up with a fraction here. I need more space. Let me get rid of that stuff. All right, so what do we get out of this? We got 7x, and I got negative 12 minus 7. So that'd be negative 19. But remember, we want 1x, not 7x, right? Yeah, there is an equal sign there. So how do I make a 7 to 1? Bam, just divide it by itself. So that's going to be 1x now. And again, I wouldn't expect to see fractions like this, but looks like we found one. And that would be the final answer right there. It's negative 19.7. So when we check this, right, I would definitely use a calculator to check it, but yeah, I would type it into the calculator just to make sure that's true. Yeah, so just double checking all my work that I performed right here without putting it into a calculator. It looks pretty good. All right, a problem like this one we should be able to do. So again, just looking to combine like terms because there's no parentheses. Negative 8 minus 2 would be negative 10. So now negative 10 equals x minus 5. But I don't want that minus 5. I just want to zero that out. So add 5 to both sides. So that is a 1x, by the way, which we want. Negative 10 plus 5 is negative 5. And that should check off. Negative 5 minus 5 is negative 10, which is what we evaluated when we did negative 8 minus 2. So that is the solution to this equation. And again, I can box that in with some confidence right there. Let's go through the work on this one on how to check. Now, we do need that negative 8 minus 2, right? And I'm sorry, I'll start from the beginning. So let's go back to the original equation. Negative 8 minus 2 equals x minus 5. Now right here, we just showed that x equals negative 5. So I am replacing that x with negative 5. And I just want to make sure that this is a true statement. So negative 8 minus 2, that's negative 10. It should equal these two together. Negative 5 minus 5 is also negative 10. So since that is true, this one checks off. So I know for sure that the answer x equals negative 5 is the solution to the original equation up here at the top.